Okay, Applaus für Bre Pettis und MakerBot.
Hello, and hello Berlin. It's good to be here again. This is one of my favorite places to come and be inspired and meet people who are doing interesting things in the world. And I get to be here in front of all you, and the thing I look forward to is afterwards when I get to meet all of you. So, without further ado, I'm going to talk about 3D printing and stuff like that. But I heard a lot of you are bloggers. So, if I were the boss of you, and so I've been I did blogging for many years, since like 2004, 2005, getting paid to do it and making a living off it. And if I were going to say one thing, if you're going to be a blogger and want to make a living off it, is just do something interesting and then always push that forward. End of rant about blogging. So, now I'm going to talk about a machine that makes almost anything. Oh. And we can see this, and it's good. Oh, good. So, we were promised this future, growing up, that, we were going to live on the moon if we wanted to. That was going to be a real option for us. Or a space colony, or just, maybe we'd be cryogenically frozen and wake up 500 years later in a foreign place. And flying cars and all that kind of thing. And we were promised a machine that would make almost anything. Well, I can't do anything about the flying cars, and I can't do yet. And I can't do anything about space stations, although I do want to build a moon base, or at least the robots that will build the moon base. But I can do something about a robot that can make almost anything. It's tea, Earl Grey, hot. So this is a MakerBot, and it moves around. It goes like this. And this goes up and down. And this material right here is ABS plastic. And this isn't a tube, it's what the actual material. And this is the same material that Lego is made out of. And so it's nice and durable. This is a whale tooth from a natural history museum that's just been scanned and uploaded to the internet, and I downloaded it and printed it out. And I like it because it's really durable stuff. You can you can do that kind of thing. I once was telling somebody how strong it was. I'm like, you can stand on it, no big deal. And he put it down on the ground, and then went like, oh! Yeah, and he broke it. But yeah, needless to say, it's pretty strong. It's like stepping on a Lego. It's durable. This is a picture of a guy out of Belgium named Unfold. He scanned his face and uploaded it to the internet. He's probably the most replicated human being on the planet, in that he shared himself, literally, and it's a great model to download and print out. If you ever get a MakerBot, download Unfold's head and print it out. This is just a picture from an art show, just to show you what it looks like. And this is at the Bot Cave. So I'm from Brooklyn, and we have a manufacturing facility where we pack and ship MakerBots and send them around the world. It's been going really well. We've been doing it a year, and just 2 days ago, we shipped our 1,001 MakerBot. Yeah. If I think about that too much, it just blows my mind, because that's not just like people who bought something and then put it together. That's like people who bought something, put it together, and then can make anything and share it with the rest of them, and then they can make the same thing or improve it and move on. So if there are any MakerBots, if there's anybody who has access to a MakerBot, I know there's a few of them here in Berlin, stop by, yes. Make sure you stop by and see me. I have a special gift for you. So MakerBot came out of NYC Resistor, or it was forged in the friendships that were made at NYC Resistor. And NYC Resistor is this thing as a community clutched together. And basically, I was in a group called HackerBot Labs in Seattle. I moved to New York. There wasn't a hackerspace. I came and I toured a bunch of hackerspaces in Germany, C4, Das Labor, and one in Vienna, MetaLab, and a bunch more. And basically it was like, okay, the Germans have had it had hackerspaces nailed since 1981. I think we can do this in New York. So we went back and we started this, and we have a lot of fun. This is this is Barbot, and Barbot has a red button on it. At least in the first incarnation, this was a really bad idea. That was like a random button, and when you pushed it, it made a drink for you. And you could make all sorts of really nice drinks, like gin and tonics and Sazeracs, blah 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 blah. But nobody can resist a red button. It's very dangerous. So you push the red button and you get a drink that's like gin and tequila and orange juice and tomato juice, and like it's wrong. But you have to drink it because a robot made it for you, right? This is Diana Eng's work. So she's really into fashion, and so she creates these electronic projects that integrate with clothing, and she's a pro. This is from her show she had recently. This is what's called a Twitchy, which is it's really a robotics platform. It's basically an Arduino optimized for servos. So this is a little computer that you can buy and hook up to little motors, and then you attach whatever you want to it. In this case, doll parts. All it does is it twitches, and it's got a tilt sensor in it. So if you twitch it one way or another, it gets agitated. It's disturbing. So this is an MP3 player. This is Matt Joyce's project, and he wrote this up, and he's very proud that this has been on the TSA's blog twice. Now, if that's a metric for a good project, that's a great metric for a project. If you can, yeah. This actually showed up at NYC. You can actually buy grenades pretty easily on eBay. And of course, they don't have explosives in them, but it got shipped to NYC Resistor without a name on it. So I think it was Zach opened it up and was like, great, somebody's sending us grenades. There was a new policy after that, like no weapons or sent to the space without a name on it. Okay, so let's get back to the MakerBot. So you want to make something. Maybe you want to make some gears. These are elliptical gears. These are fun to play with. Or whatever, you just imagine something, and you're like, okay, let's do it. So there's a few ways you can do it. The first is actually not to imagine something, but to browse. We made this site called Thingiverse, actually before we made MakerBot, because we kept going around to people and saying, hey, you're going to be able to download things just in the same way you pirate books and music and all these kind of other things. You're going to be able to download things, design files for objects. And people were like, that's so cool. Where do I go to do this? And we're like, So we made Thingiverse because we wanted it. And at the time, we had just gotten a laser cutter, which is probably the best tool ever. If you can get 20 people together to spend $1,000 US, which is like €1, then you can get a laser cutter and make all sorts of things. It cuts things out that are flat. The body of this machine is made on a laser cutter. So we had all these designs, and we shared them, and then people downloaded them, and then they made them, and then they made them better. We set it up to be like absurdly Creative Commons compliant. So when you go to something, you can actually click on a button that says, I made one, and it either sets it up to show you upload a picture, and it says it's a copy, or you upload a new design because maybe you downloaded that thing and improved it. You can re-upload the design, and it automatically attributes the original person and sets that all up. So this is something made on a MakerBot, and this is a bottle opener and a bottle cap from a Brooklyn lager. Hold on. This talk is entirely Club Mate powered. I just got here off a plane. Okay, so this is cool. This is actually an expensive one. Zach made this one. He's one of my buddies, and I've got the much less expensive one in a pocket here. This one uses a quarter, which is 25 cents, and the one that Zach made, the next generation is one that has a penny, which is like, because this is only like 25 cents in material, this is like half the cost. You're not all sitting together, otherwise I would pass this around. So I'll just have things out, and I'll be outside in the front, and you can come up and touch these things, because it's more fun to touch them than to look at them. And if you see me and it's nighttime and we have beers, we'll just open them with this. Okay, this is a really good projector over here. Normally you can't see this very well on a projector. You can see it's a 1 teaspoon and a 1/2 teaspoon. And just because he could, he made a 13/16 teaspoon. That might just be the perfect amount of cinnamon for the ultimate, cupcake. You could download this and print it out. You need some Legos, but this is a Walker, Janssen Walker. He makes these contraptions that walk all over beaches, and Mark made one that walks all over your desktop. This is so cool. So Will needed a camera, lens hood. His brother needed one. He had these 2 cameras, and it turns out there was never a Yashica. This is an old camera with like film. Antiquated technology now. But he wanted a lens hood, and they didn't exist. You couldn't get it on eBay. There was just no way to get one. So Will spent about an hour and designed one up, and gave his brother the ultimate present that he could get nowhere else. And then he uploaded it so that everybody could have a Yashica lens hood if they wanted to, and if they wanted to print it out. The design's out there for anybody. This is one of the things that's important is to enjoy technology. And one really fun way to do that is by playing pinball. And when you play pinball, pinball is kind of old school. It's hard to get replacement parts. So one of the things this machine is good for is making replacement parts. This is a replacement pinball flipper. Dominic came up to me at a conference in Seattle and was like, "I'm Dominic. I'm the guy who had the CAT scan and then made the doctors give me the files because they're me. And then I took, apparently with a CAT scan or an MRI, I'm not sure which one it was, to be honest, but you can go through the data and you can choose the density, and you can isolate densities of stuff inside yourself. And so he isolated the bone, his skull, and his teeth actually were different densities, so they didn't show up. And then he uploaded it to the internet. He didn't have a MakerBot, and he just thought, okay, future replacement part or something, right? And so I meet him, and he's like, "Yeah, I'm the dude who uploaded his skull to the internet." And I'm like, "Awesome! We're printing that out right now." And a MakerBot can print out something about the size of an apple, big apple. Well, not like, we call it the Cupcake because it can make something a little bit bigger than a cupcake. But it turns out it can also, I love this picture because it just shows that you can see it's actually his skull. When we make a bigger machine in the future, we'll be able to just seriously print out replacement parts. And actually, we just got we started selling material this year, called PLA, polylactic acid. And this is a plastic that you've probably seen around. It's the biodegradable plastic, and some plastic cups and plastic forks are made out of this stuff. Well, it turns out we get it by the pellet, and we send it to a place in Ohio where they take these little nubbins of PLA and send it through a room-sized machine, and we get this stuff, and you can print it out. It actually comes out, and it's nice, it's clear, it's just begging for LEDs. I went to CCC, I was here for CCC, where it was, the theme was Here Be Dragons, so I found a model of a dragon on the internet, and I chopped its head off and printed it out. If you have a 3D printer and you can make an X-Wing fighter, you have to. This is Zago, Eberhard Wrench. This is a dude in the south of Germany who's awesome. He's doing so many cool things. This is one of them. This is like a referee whistle. So you've got a MakerBot, and your kid has to go to soccer practice, and the referee is like out sick, and you're going to do it, but you don't have a whistle, and you've got 15 minutes, you can do it. And the cool thing is it prints out the little ball inside it, and you just snap it off with a pair of tweezers or whatever you can stick in there to snap it off. The thing that I love about this is he uploaded this to Thingiverse. We've got it set up so it's integrated with Twitter, blah, blah, blah. And I was on the N train in New York going into Manhattan to do a MakerBot demo. And I got the thing alert, which is if you follow Thingiverse on Twitter, you get an alert every time anybody uploads anything to Thingiverse. And I got a thing alert as the train's going over a bridge. And I'm like, whistle, that's cool. So I get to the place, I download it, and I print it out. He uploaded it to the internet, I printed it out half an hour. And it was the exact same whistle that he uploaded. So you can't get a whistle from the south of Germany to Manhattan in half an hour unless you put it on a missile, which that's bad. And we just got written up as being the closest thing to teleportation in IEEE, which is an absurdly conservative, old school kind of particular. Anyway, Legos. We're not going to put Lego out of business. It takes about 10 or 15 minutes to make each Lego. But the cool thing is these are some guys out of Vienna, Wizard23 and Marius Quintel, and they're really into this kind of thing. And they made a script so that basically this is a dynamic object. You can put in, these are 2x4 Legos. Well, they actually have it set up so you put in two variables, like 3 and 17, and it generates an STL file that's a Lego that is not made by Lego. A 3x17 Lego block doesn't exist unless you make it yourself, and now you can. So they're total badasses. So there's this guy in San Francisco who his handle is MakerBlock, and he got a MakerBot to make Legos. But he decided he wanted to he and a bunch of other folks decided that they would come up with a new system for a kind of configurable play system. And this is what they came up with. There's 7 different types of thingamajigs, and you can put them together in different ways. And if you want, you can download one and make it different. This has a circle with 2 eyes at the top. You could put your own head on there or whatever you want, and then upload it, and then everybody who's into this kind of a thing could print out your new design and add it on to their contraption. This is Wizard23 out of Austria again. He needed a replacement knob. He just did it. This is a Dremelfuge. This is a guy out of Ireland named Cathal Garvey, and he's a superstar in the MakerBot world. He made this thing called a Dremelfuge. And a centrifuge is something that takes test tubes, and you put blood in it, and you spin it around. It goes very fast, and it separates out your white and red blood cells. And you can do other things with it too. But this is a contraption that usually costs about $1,000 US. And if you have a Dremel, you can make one on your MakerBot, and it costs about 25 cents in plastic plus your Dremel. And you have a contraption that if you turn the Dremel, if you're using glass beakers, and you turn it up all the way, the glass shatters. So it's actually super ultra powerful. You have to danger in a good way. This is a good story. So this is a dude named Finn Flood who was going to Iceland on Saturday, and it was Friday, and he decided he wanted to pop the question to his sweetie, and but there was no way to get go to the store and buy a ring. So he printed one out. And the cool thing is he gave it to her, and he's like, I have something for you. And she opens it up, and she's like, this is so cool. What is it made out of? Perfect woman. And And he says, he's like, I'll tell you all about it, but I have a question for you first. She said yes, so it's sweet. So you can download all this stuff, and this is just like, I just showed you like 10 things. There are 1,000 things that you can download and print out on a MakerBot, and there's more every single day. It's like my favorite thing to do is wake up in the morning and see what is in the is in the library of downloadable and printable objects for anybody. So for modeling, so I also want to talk a little bit about, I want to make sure I come back to this. I want to talk a little bit about just how powerful it is. And there's a whole economy piece here of, I'm sure I'll get to this, but I'm thinking about it now, so I'm telling you now. So if you, one of the cool things about this is, it comes as a kit and you put it together, and it's a little bit fussy. Every once in a while the extruder breaks and you have to fix it, but you know how to do it because you put it together yourself. And, but the cool thing is once you have it, you can make a bunch of things, and it's very, very cheap. Because the plastic is $10 a pound, and this is like 1/3 of a pound. So this is like $3 or $4 in plastic. Because it's really cheap to make stuff, you can just try things out and iterate. If you don't like the way it looks, you can make it bigger, smaller, put a hole in it, whatever. Okay, so how do you do this thing? There's a bunch of really cool software that's free that you can just download. And actually, let's see if I have, well, maybe I don't have the internet. But there's this, if you're on the internet right now, you can go to openscad.org. Probably not my favorite name for a design program, OpenSCAD. But it's the coolest design program out there right now. If you are a programmer or you know a programmer, this is the 3D modeling program for you or them. Because you can basically program objects, and they're dynamic. You can go back and change variables, and it changes the whole object. So you can say, okay, at point XYZ, I want a sphere with a radius of 5 units. And at point XYZ, I want a tube or a column at this location. And then you can do a Boolean operation, which is like a subtraction operation. And then you have a hole in your sphere, and you have a bead. And you can change all the variables, and it's absurdly cool. And if you think like a programmer, this is the program for you, OpenSCAD. If you don't think like a programmer, probably the easiest place to start is a tool called Sketchup, which is made by Google. And they have a free version, which is actually really powerful. And there's a hack to get STL files out of it. STL file is the kind of file format that the MakerBot craves. And it's kind of like a text file or a doc file. It's very cross-compatible. But okay, so SketchUp is pretty straightforward. Kids get it. You can get it. Like in terms of like it's one of the ones that really makes sense. There's a bunch of other free ones, and if you're getting into this, that's a great place to start. Actually, a lot of people just stay with the free ones. There's another program called Blender, which actually has a lot of people in Berlin working on it, and they just came out with a new version that has a new UI that is makes it a lot easier to use. Okay. So I didn't have a picture for this, but there's a lot of them that aren't free. And there's a program called the Libre. There's AutoCAD, which is very old school, been around a long time, very powerful software. Inventor, SolidWorks. There's a lot of them that you can get and pay anywhere from $100 to $5,000 US. And they can be very, very powerful. And they're very cool. I haven't played with them because they're just expensive. So let's say you make something I made a fake watch, and then you saw that in SketchUp. It looked like this in SketchUp. And then this is what it looks like when you slice it. Because you make this digital object, and you can turn it around and look at it in any way you want, and animators have been doing this for years. And now you can make physical objects, and it's you do it the same way. It's a little bit trickier because with animation, it just has to look real, and it can be the actual geometry of it doesn't have to actually be possible in real life. But with physical models, you have to make it so there's an inside and an outside and that kind of a thing. Anyway, you take that model and you slice it up in a program which is open source called SkyneForge. And SkyneForge basically turns a 3D object into a toolpath, and it makes it into a lot of layers. And you can actually, if you run your fingernail across an object, you can hear there's a little scratch. That's my fingernail going over the layers, because this is built up out of lots of layers. And this is a picture of one of the layers where you can see each color is a different time that it starts and stops. And it does the outside first, which is red, and then it goes, and then there you go. Then you load it up into a program called Replicator G. And Replicator G is just like a really easy, so when you slice it, you end up with this thing called Gcode. And Gcode is super easy. If you can see it here, it's actually like X, Y, Z coordinates, and the F1440 is what it looks like. That's the speed that the machine's going at. So it says, go to this location at this speed. It's very simple, straightforward. Gcode is like basically one of the first things people did with computers is they made machines move. And of course, they wanted to make mills move. A mill is something that cuts things. This is an additive process. It builds it up. A mill is something where you put a block of metal or wood or foam, and there's like a high-speed drill, a milling bit that goes around and it takes everything away. Same kind of deal as this, but like that takes it away. This adds it, that takes it away. Same kind of code. And they made this, they used to use paper tape and punch cards. Then they converted to, when they got the computer, they converted all that, and it's basically still the same. So when you've got that, you just print it, and you get it moving. And like I said, this goes back and forth and forward and back, and then you have a thing. Okay, ta-da! Oh, so this is a watch I just made up for a fashion statement, because I never need a watch because I have a phone, and I thought it'd be fun. And yeah. Okay, so the guy from Ireland I mentioned who did the Dremelfuge, had a mouse problem. He had a mouse in his house, and the traditional traps wouldn't catch it. Like, it was too smart of a mouse. It was smart. So he decided to put a bounty out, a reward on the internet. And he said, okay, if anybody can build a better mousetrap that catches this mouse, I'll give you $25. And the next morning, there were 8 designs on Thingiverse. So now right now, he's in the process of printing them out and testing them. He's printed out the first one, and it's actually not this one, but he printed out the first one, and it didn't work. The mouse got in, ate all the food, and escaped and peed all over it. So he's going through each one at a time, and if one of them works, he's going to send that person $25. The cool thing is all these things are shareable, so if you see one and it doesn't work, you can download it and change it and fix it the way you want it, and you can yeah. It's like modifying somebody else's blog post, except it's physical. So one of the cool things is that if you solve a problem and you share it, everybody in the community benefits. So if you build a better mousetrap, everybody who has a MakerBot is going to be able to make that mousetrap. Oh, and he specified that it wasn't kill traps, because he didn't want to kill anyone. He didn't want the guilt of killing a mouse. But so you'll be able to catch mice and take them to the country or whatever you do with them. So this is the Plasteruder. So I'm going to tell you a little story about how the community works together and shares. And so the way this works is there's some electronics on there, and the plastic comes in through the top. But there's a motor here that you don't see there. It's like right here. And really slow but high torque motor. And then it gets heated up, And it comes out as like a piece of spaghetti, a very fine angel hair spaghetti. I printed some out earlier to warm it up. And it kind of looks like curly hair or something like that. And the fact that this works is pretty amazing because most 3D printers cost like $100,000, and this one costs under $1,000. So that's kind of magic. But it's not perfect. There's still a bunch of things we're working on to improve. We're always improving it. And one of the things was that when we started, we needed this nozzle to get to 220 degrees Celsius, which is hot. And you want it to stay that hot because if it gets too much hotter, the heating element will burn out. And if it doesn't get hot enough, the plastic doesn't melt. So we had a very inelegant, like not elegant, not pretty solution that basically said, okay, 220. When it gets to 225, turn it off. When it cools down to 215, turn it back on, and it would just bounce back and forth. It worked, but it was not pretty. Well, somebody who got a MakerBot, a guy named Tim Myrtle, he implemented something called PID, which you don't need to know what it means. But what it means is that, well, you don't need to know PID, but the idea is it's very elegant acceleration math. And so he went in, and because all of our software is open source, he pulled out all the 2 lines that basically said, okay, bounce back and forth. And he wrote that to be really pretty and put a nice chunk of code back in there. We uploaded it to GitHub, which is a way to share code, and sent an email to Adam, who is our software guy at MakerBot. And Adam had it on his list to do it, but it wasn't at the top of his list to implement PID. And so the community basically sorted this out because they wanted it fast. And then the next day, he released it so that everybody who had a MakerBot could get it. And it's just, now it goes up to 220. And it's like, it's great. Okay. So one of the cool things about this machine is that we made it to be absurdly hackable. We wanted people to play with it. We wanted people to push it. We wanted people to do stupid things with it. And so this is one of the stupid things that we've done with it. We decided we would take this plastic tool head out and stick a syringe in here. A syringe is like kind of a thing that you like for injections. But instead of injecting things into our body, we decided to use it to inject things onto this moving platform. So we went to this hack day, which is like a hackathon, where we didn't sleep for 36 hours, and we came with this contraption that was just a prototype, and we turned it into something called the New York Toast, which is the idea of 3D printing on toast. This is a horrible idea, but very tasty. So it turns out that we took an API for news and weather and converted it into breakfast. That's maybe an American joke. So you could get, the resolution of peanut butter is 12 PBI. That's peanut butters per inch. PBI. It's not that funny. The idea of being able to print out the weather so you don't have to look out the window. You can just go straight from bread to toast. Emergency broadcast system, tsunami warning. Okay, enough of that. The cool thing is that's a thing that we finished the prototype, we're doing the documentation, and now instead of being able to print with plastic, you're going to be able to print with, absurd things like peanut butter and jelly and marshmallow and what else did we try? Yeah, frosting. Frosting works really good. But then you're also going to be able to print with other cool stuff. There's a bunch of other stuff you can stick in a syringe, like UV curable silicone, which is like a plastic that rubber things are made out of. You can print with clay. That's something I can't wait to do. I'm going to print out a teapot and a tea set. And we're going to be able to do that very soon. I'm very excited. So the idea of this is not just something that you get and it's not like a microwave or a toaster where you get it and then it just does something for you. You can get it and then hack it and do other things with it. Okay, so some things to think about with this kind of a contraption is this idea of abundance. You know, we live in a world where you want to get something, but there's only so many of them. And with this kind of with a machine like this, you can have as many as you want. It's just based on how long it takes your robot to make it. And so, if you don't have to buy things from a store and have them manufactured someplace, probably very far away, and then put on a boat, and then put on a train, and then put on a truck, and then you drive to a store and you get it. If you can bypass all that stuff and just download things and print them out at your house with very inexpensive plastic that's easily acquirable, then this whole idea of an economy shift happens. And I don't know exactly what will happen, and I don't think it's going to destroy, and I think it's going to go in parallel with, you know, old school economy kind of stuff. But I think there's something here that is going to be a really interesting shift. The other cool thing about it is because the file format is really easy to download and change, you could download this bottle opener and put your name on it, or make it giant for giant bottles of beer. Yeah. So this kind of idea of being able to make things the way you personally want them instead of what's available is very interesting. There's a guy who is working on a 3D printed clock, like an actual like tick-tock kind of grandfather clock kind of a thing. And I love the fact that right now, if I want a clock, I probably go on Amazon or I go to the store and I find out what's available. With this, I have to just go down and look at what files are available and if I can use them or modify them. So there's something really interesting about, you know, normally you buy like something and it's got a brand name on it, but if you can download that thing and take that brand name off and put your own name on it, it gets kind of interesting. So this is the beginning. I'm telling you about this and I'm super excited about it, and it's happening like today. But it's still the beginning. There's still like so many possibilities for what could possibly happen. And it's going to happen because people like you get excited about doing something, whether it's practical or absurd, and decide to do it. And so like there's a frontier here where one of the things that happens when I'm talking to people is I say, oh, can it do this? And almost every single time I have to say, no, it can't do this yet because someone like you hasn't done it. So something that I'm really excited about that I just learned about recently is the Open Prosthetics project. And this is a project to make, like right now, if you don't have a limb, there's a whole process, and I'm not an expert on prosthetics, but there's a whole process that's kind of tricky to get one made for you and manufactured that costs a lot of money. The Open Prosthetics project is a project that anybody can participate in, and they've taken a bunch of these kind of prosthetics and made files. So this is actually, you can download, there's three parts here, and you can download each one, and you could print them out on your MakerBot. Now these are probably not going to last very long because they're made out of plastic, and this is something that takes a lot of wear. But this is something that you could use and then make another one, or maybe you want to just try out a bunch of designs to see which one works the best and then get it made in metal. Something nobody has done yet is taken the plastic and made molds from it and then cast it in metal. I would really love to do this, but I don't have a forge or really know much about that. I could figure it out, but I'm building robots these days, and somebody else needs to figure out how to take plastic and make a mold and pour metal into it. And it could be nobody's done it. And if it's you're going to be the first person to do it. And you're going to be a badass. And everybody's going to be like, that's the badass that figured out how to turn plastic into metal. So with the whole syringe thing that I was telling you about, with what we call the Plasteruder, where you can stick things into a syringe and make them, there's a group of people who are printing out organs. And the idea is you take liver cells and you create a liver. And there's probably a bunch of different kinds of cells for the outside and inside. I'm not an expert on livers. Maybe you are. And this is another one of the frontiers. There's a whole DIY bio thing going on that if you're looking for something to blog about, like it's one of the things that's going to be coming up in the next, it's been happening for like 10 years, but it's kind of beginning to hit mass, kind of the mass world. So this nearly possible, this feeling that there's things that are possible that haven't happened yet, is this feeling that just like kind of, it sort of aches for me. Like there's things to do and they're not done. And I have like kind of an obsessive compulsive disorder that like when I start things, it's really hard for me to not finish them. So I'm willing to stay up late and do things. But I have an extreme amount of self-control, like, and actually there is a sleep barrier. Like there's so many things to do and I can't do them all. So you're invited. There's so many wonderful things to do and there's not nearly enough people working on them. And you're invited. This is a picture, this is one of my favorite pictures. This is a thing called Maker Faire, which happens in California every year, and now this year it'll happen in Detroit and New York City. Come to New York City if you can. And Maker Faire is something where people get together and share things that they've made, and it's cool. So these are a bunch of young girls checking out the MakerBot. What I like to think about the fact that there's a bunch of young people who are going to grow up around a MakerBot and grow up around rapid, prototyping and personal manufacturing. Like instead of having to think about, where I'm going to go get this thing made in a factory, they think, okay, do I want to buy one of these things or do I need to make one of these things in my living room? And I love the idea that that's just an option that young people specifically will have that option growing up in living rooms where there are, manufacturing equipment. So that's me. I'll take questions now, and if there's no questions, I'll probably keep talking, but I'd rather have questions. A pleasure. Thank you very much.
Fragen jetzt bitte ans Mikrofon dort gehen. Du müsstest aufstehen. Das muss doch mal drin. Bitte was?
Oh.
Ja, ich glaube, er kann da schnell hinlaufen, oder? Hier vorne.
Get ye to the microphone. I haven't drank nearly enough Club Mate.
Thank you. Oh.
You're welcome.
Oh. Everybody awake? No. One question, do you cooperate with the whole Fab Lab movement? From the MIT, and then there's in Sweden and so on and so forth, and Fab at Home, and because they have this bigger concept of, you mentioned it, laser cutter and more machines.
Okay, so to repeat the question, so basically there's a community of people besides my company who's creating all sorts of machines that you can have in your home. And some of them are 3D printers, like a MakerBot. There's a RepRap project, which is we actually were really, Zach, Adam, and I all hacked on the RepRap project for a long time. These electronics were actually designed by Zach for a RepRap, and we modified them. We love to participate. Yes, so the answer is yes. So, but basically for everybody out there, there's all sorts of projects, not just ours, that if you're interested, instead of making things that extrude plastic and building them up, but you're interested in things that cut things, and there's all sorts of possibilities to participate in those communities as well. Really, it's about finding your passion and jumping into it. If your passion is personal manufacturing, there's all sorts of ways you can jump into it. He mentioned Fab at Home, which is out of Cornell, RepRap, which is out of Bath, England, and is a very spread out project. And MakerBot, we're in New York, but again, these are all global communities. They just kind of have centers where they focus. So you're invited to participate not just in this project, but all sorts of other fabrication projects. It's happening. It's exciting. Do it. Thank you for the question.
Sind noch Fragen? Dann, ja.
You are a commercial project, and you cooperate with these open source projects. And what exactly is your relationship with these open source projects, and how did it come to these relationships between you?
Yeah, it's interesting. We're an open source project. We are absurdly open source. You can download every single thing with this machine. You can download the electronics and make them yourself. You can download the laser cut files and laser cut them. Out of the 1,001 machines, 6.5, one of them's in process. 6 people have made their own, and it's not cheaper. It's not easier. But people are like, I'm doing it myself. And the cool thing that we like about that, and one of the reasons we open it all up is, well, first we get to build off of open source projects. And the second is that the people who do it themselves give so much back to the community by trying new things, by experimenting. And then they know it better than anybody else. So in terms of our relationship to open source projects, we're an open source project, and we're friends with the other projects. And our kind of saying is we play well with others. If we see something that's open, we give attribution, and we respect licenses because we want that to be the world we live in. Where instead of having to worry about something, instead of having to worry about downloading something and being able to do something with it, we want people to just feel absolutely free about being able to work on this, modify it, and make it better, and then hopefully share it with everybody else when they do that. Was that your question? Cool. Yeah, open source physical. If you're not, how many of you are involved in some sort of open source project in one way or another? Okay, cool. Yeah. Open source is. I'm going to resist going on a rant about education, but, I'm going to just do a small one. So basically, if you know anything that you feel proud of or that has made a difference in the world, or you've pushed anything forward, I would just encourage you to share it in any way possibly you can, whether it's on your blog or share it with a community or even just share ideas, because we're in a time right now where schools don't really work anymore. People can get whatever they want from either friendship networks that are locally in real life or from the internet. And this kind of, if we all share the infrastructure that we have, it makes it a lot easier for young people and people in general to be innovative and solve the problems that we're all going to face together as a world. So that's my little rant about that. Any more questions?
Eine sehe ich noch. Over there.
Oh, good.
Actually, how long does it take to put this stuff together when you buy the package from you, and how technical abilities are needed?
That's a good question. I can do it in 4 hours, but I've done it like 20 times, and it takes time but most people, it's like a weekend with a friend. And then, because there's instructions and it's a wiki, and because it's a community project, we did it so that anybody could modify the wiki, which turned out to be a little, if you've ever dealt with a collaborative wiki, has its challenges. But the benefit is that when people look at the instructions and they find ways that it could be done better than we've shown people, they're like, no, the instructions for this section suck, do it this way. And you have to kind of decide whether that's, we go through regularly and we kind of say like, okay, that's crazy. Or that's a good idea, that's one way to do it, but anyway, yes, we basically say like, it's the same tools to put together IKEA stuff, but I would say like, it's a little bit harder, but we have better instructions. I actually said that to somebody and he's like, my mom does the instructions for IKEA. It was kind of a little awkward. So, yeah. Eventually, we're moving towards, our goal is to make it easier. And so, like, we are working on the hardest part is the extruder right now, because it's just hard. And we have another version of that coming out sometime this summer. And we're kind of obsessed with making things reverse compatible, past, future compatible, basically. So like when we came out with a heated build platform, we made it so that you could just get the new part and put it on your older MakerBot. So there's kind of all sorts of stuff we do with that too, to make it so that when you get it, you don't have to worry about it like going out of style.
Hier vorne ist noch eine Frage mit dem weißen Hemd.
Okay, thank you. Here, the question. Yeah. You mentioned the RepRap project. What I like about that is that they try to make the machines, that the machines can produce clones or another machine so that they really spread. Are you planning something with the MakerBot? And that, because you have now the wooden case and what's actually nice, but probably you can't print it out.
Yeah, it's funny. So we started with the RepRap project, and that was one of our inspirations, and with Fab at Home. Fab at Home actually is a couple of years older. But the cool thing about having a printer that's self-replicating is that it can make parts for other printers. The downside is if you want a machine that can make copies of itself, you have to have a machine that can make copies of itself. So there's a recursion loop there that it's like it's a classic chicken and egg problem. So like we literally got really frustrated with that, and that's one of the reasons why we made a chicken. And there's probably about like, there's probably, an extra 500 RepRaps in the world because they were made on a MakerBot, and I love that.
Da oben sind noch zwei Fragen.
What are the next things you like to improve on this machine? Like better resolution or more speed?
Yeah. Yes. I want to make it, more importantly, I want to make it more, I want to have it to break down less. Right now, every once in a while it'll break down, and we're fixing that. Like, the next extruder is going to fix that. This is still rock solid. I've been running this for like 5 months, and it hasn't broken. Now, I've said that out loud, so I'm sure like I'll go out there and it'll be like, ah. But making it easier to put together and making it more reliable is number one. In the future, I would love to have a bigger machine. Everybody's always like, great, it can make things this size, but why can't it make things this size? And like, I'd like to be able to print out sandals. I'd like to be able to print out, you can actually, there's a design on Thingiverse for printing out eyeglass frames, but you have to do it in parts and glue them together. So I'd like to be able to do it all in one. So in terms of more accuracy, that's going to happen. We want to do micro-stepping, which means that instead of like, right now the XY resolution is about 300 dpi. And with micro-stepping, it'll be like 16 times that. So it'll be absurdly accurate. And the extrusion comes out at like 1/3 of a millimeter, so there's only so much accurate you can get with that. Like, you can only be so accurate with a marker that's a certain resolution, I guess. Yeah. So yes, yes, yes. All that stuff is like
I think we'll go for 2 more questions, okay?
Okay.
Yes, hello. I'm interested, what kind of company is MakerBot Industries, and what is your take on the organizational structure with the commercial on one side and the open source part on the other, or both of them mingling up somehow?
Open source and commercial stuff. It's actually, they make surprisingly good friends. Well, maybe, it's not surprising to me, it makes sense, but for some people, they're like, what? And basically, in the world of the internet, if you have a company and you're not sharing, you're probably doing something wrong. So, we're an LLC, which in the States means we're a business, and that we have to pay lots of taxes, and that we can pay rent. Last year we didn't pay ourselves. This year we're like making enough to pay rent, which is awesome. And we're going to get health care. But we probably won't have, and we won't have to wait for our country to do it, which would, yeah. So that's I'm pretty excited that we have a business that can support us and lets us, devote our time fully to kicking ass and pushing things forward.
Can you make it a little bit more concrete? How many people are making a living out of it?
Yeah, so we have Zach, Adam, and I are the co-founders. And then we have another 6 employees. One of them has a baby. And, that baby gets fed and all that stuff.
Okay, thank you.
Yeah, thank you.
So, Bre, you said you built a chicken, and the plan was not really to have a self-replicating machine, but as far as I understand, some parts of the MakerBot are actually printed on the MakerBot, and you have a special program for MakerBot owners, don't you?
Yes. Hi, Jens.
Hi.
It's good to see you. Yeah, so these parts right here, when you come and see the bot later, you can see these are printed on the machine, and you can print out, you can download and print replacement parts over email. When we did these parts, we actually had a problem where we had to make too many of them. And we didn't have enough time. Like, it takes 15 minutes to make each of these parts. And when you're making, goodness gracious, we make 200 a month now. And so that's and there's 4 of these, so that's 800 parts times 15 minutes. That's 200, that's a lot, that's 200 hours of printing time. And so what we did is we went to our community and we said, hey, you have more MakerBots than we do. And we paid people to make parts for other MakerBots, which was really cool. We've since gone and made it was too many and our community couldn't keep up. So we had to go to a manufactured part. But these printed parts are actually better than the manufactured part that we have. So you get your MakerBot and you can immediately print out an upgrade, which I love. So, okay, I think that's the last question.
Yeah.
Thank you very much.
Bre Pettis, thank you very much.